In this video, we're going to go over the process of drawing Venn diagrams for various expressions. The first problem, on the left-hand side of this equation, we have a compound statement. So we have B union C in parentheses, and that's intersected with A. So to draw that, we're going to first pay attention to the parenthesized expression and draw that first. So B union C means everything that's in either B or C. So I'm going to shade everything that is either in B or C. So like that. And then we see that we're supposed to take that shading and intersect it with A. A is pretty easy to visualize. It's just the stuff that's inside of the circle A. So inside the circle A will also be shaded. And so it's fairly easy to see that if I shade everything in A, oops, it looks like that, and it's easy to see the stuff that gets shaded both ways. We're doing an intersection here, so I want to know which parts of the Venn diagram were shaded both in blue and in red. And so that'll be the part that's in here. So this shaped thing. So that's the region that is shaded both blue and red. So that would be the shading for the Venn diagram for this expression. Similarly, to do the other one, other side, I first have A intersect B inside parentheses, and so I would shade that first. So this is what A intersect B looks like. And then I want to take the union of that with C. So remember, C is the whole circle. So all of this gets shaded. And now, since this is a union symbol, we're not taking the stuff that shaded both blue and red. We're taking the stuff that shaded either blue or red. And so the resulting shading for this Venn diagram will look like this. It'll be all of C plus this little pointy thing sticking in. So it's clear at a glance that these things, these shaded regions, the black shaded regions, are not the same. So these two are not equal, so these two expressions are not saying the same thing. And then to follow up with what I said in class, it would be another way to think about it would be that the logical expression P and Q or R is not logically equivalent to the expression P and Q or R, just translating the Boolean symbols and or into, the intersection and union into and or. And what we expect is that the truth table for this expression is different from the truth table for this expression. So the Venn diagrams give us a visual way of thinking about sets, but the truth table would also give us a way of verifying that these two expressions are not the same. Let's look at the second one. Here we are building things again out of complex pieces. So in the first problem, I would, the left-hand side, oops, let me get my thicker marker again. On the left-hand side, I would first want to shade B union C, so that's everything that's in B or in C. All right, good enough. And I want to intersect that with a complement. Now, a complement is also easy to visualize because in blue, because a complement is all of the stuff that's outside of the circle A. So it's very easy to shade a complement by just shading everything that's not inside of the circle A. And since we have an intersection sign here, that means that we want the stuff that's shaded both blue and red. So that'll be everything inside of this sort of bizarro looking shape. So the black stuff here is the stuff that's shaded to illustrate B union C intersect A prime. Now on the right-hand side, we have B minus A, which is an easy thing to shade. That's everything that's in B that's not in A. And then in blue, we'll have C minus A. So that's everything in C that's not in A. And then we're using the union symbol here. So the union symbol tells us we want everything that's shaded either blue or red. And so that will give us all of this stuff for our final shading. And we can see that in this case, these two things are the same. We have the same shading for the Venn diagram for B union C intersect A complement as we do for B minus A union C minus A. All right, last one, home stretch. B intersects C in red, just like that. And then we're subtracting A, so, oops, blue. So that means I want to take away, from the red shading, I want to take away anything that's inside of A. So essentially that means I'm taking away the stuff that's in A. And that's going to leave me with this piece of the diagram. So what's shaded in black is what should be shaded by doing B intersects C, take away A. On the other side, the right-hand side, I have C minus A. So C minus A means everything in C that's not in A. And then I'm intersecting that with B. So B, remember, is everything inside the circle B, like that. And since this is an intersection symbol here, that means I want the things that are shaded both blue and red. And so that's going to be this piece right here. So again, we can see that these are the same Venn diagram, and so this is a true statement about sets. This is also true. It's kind of winking at you. And the statement at the top of the page is not true. That is not a true statement about sets.